All right, there are two more things about angles and circles that we need to learn. We'll do that here in section 9.6. It's called other angles. In section 9.4, we learned about central angles. These are angles where the vertex is at the center of the circle, and the measure of the arc is equal to the measure of the central angle. In section 9.5, we learned about inscribed angles, where the vertex is on the circle. In this case, we learned that the measure of the angle is equal to 1/2 the measure of the arc, or say it the other way around, twice the measure of the, oop, I did that backwards. Twice the measure of the angle is equal to the measure of the arc. There. And we also learned that if there's a chord and a tangent, it works like the inscribed angles here, where this angle A is equal to 1/2 of the arc B, or twice the measure of angle A equals the measure of the arc B. Well, there's two other types of angles, and that's what we'll get here into section 6. Theorem 9.9 says the measure of an angle formed by two chords that intersect inside a circle is equal to half the sum of the measures of the intercepted arcs. To say this again, with central angles, the vertex is in the center. With an inscribed angle, the angle is on the circle. Now we're talking about chords that cross that form angles that are just somewhere in the middle of the circle that's not the center. So when two chords that do that inside a circle, half the sum of the measures of the intercepted arc is what the angle is equal to. So if chords WX and YZ intersect the circle, then the measure of angle 1 right here is equal to 1/2 the sum of YW and YZ. So we have to use these vertical angles here that are created. So of course angle 1 is equal to this other angle over here, vertical angles. They are both equal to 1/2 the sum of these two. Or to put it differently, twice the measure of the angle is equal to the sum of the intercepted arc. We can write it this way: 2 times measure of angle 1 equals the sum of the arcs. So here's an example of what we're talking about here. Measure, or example 1, part A. If PQ has a measure of 45 and RS has a measure of 75, find the measure of angle 1. This one's simply just going to be the formula in use. This angle is equal to half the sum of 45 and 75. So just do that calculation, it ended up get 60 degrees for the measure of the angle. Example 2 over here, this time it gives us an angle and an arc. That looks like 155. It's not supposed to be. It's supposed to be measure angle 1 is equal to 55 degrees. We need to find the measure of PQ over here. So we can use an angle and one of the arcs to find the other arc that's intercepted by those two chords. So 2 times the measure of the angle is equal to the sum. So we're going to multiply 2 times 55, the measure of the angle, equals the sum, 80 plus the measure of the other angle. 2 times 55 is 110. 110 minus 80 is 30 degrees. That's the measure of QP. All right. So basically, you're either finding the measure of an angle, it's equal to 1/2 the sum, or you can find the measure of the other intercepted arc. The easiest way to do that is to multiply the angle and then subtract the other arc that it gives you. Give those 4 questions a shot. Make sure you pause the video first, of course. All right, so those are those 4 answers. Hopefully that worked out for you. Now, Theorem 9.10, we have if the vertex of an angle is at the center, the central angle is equal to an arc. If we know about inscribed angles, and now it's in the center. So this last theorem is really just about what happens when an angle, if you look at these 3 examples we're going to do, when an angle is formed outside a circle. How is it related to the arcs that are intercepted? Here's how it works. If two secants, angles formed by 2 secants, 2 tangents, or a secant and a tangent, from a point outside a circle, that's the key part, it is equal to half the difference of the measures of the intercepted arcs. So how does this compare to what we just did above? When the point was inside, formed by two chords inside the circle, is equal to half of the sum. Now it's equal to half the difference. So here's example 2, or of course we can do like we've done on the other ones. We can do twice the measure of the angle is equal to the difference of the arcs. We're basically just moving the 1/2 to the other side, multiplying by 2. So example 2 here is where we're going to talk about using two secants. So here is point A outside the circle. You'll see secant AD, secant AC, and it gives us these angle measures. Measure of arc DC is 100. The measure of arc EB is 40. So how can you find the measure of angle A? It's going to equal 1/2 the difference. Just like what we were doing above, 1/2 of the difference of those is 30, of course. Just like we were doing above, you can also, sometimes the question will ask you, it'll give you an angle that's outside and not give you one of these arcs. Easiest way to do that is to double the angle, just like we did above, and then subtract the one that's missing. Or, actually, sometimes you'll add, but we'll talk about it when we see that. Actually, we'll see something similar to this here on this one. Example 3 is formed by a secant and a tangent. That's this version here. Here is secant WY and tangent WX. And it creates these two arcs. We have XVW, or XVY, sorry, and arc XZ right here. So if the measure of angle W is 65 degrees and then arc XZ is equal to 70 degrees, to find the measure of that major arc, XVY, double the angle equals the measure of XVY minus 70. Always write out the formula. You always take the bigger arc, subtract minus the smaller arc, so that you'll get it right. So we have to add 70 to 2 times 65, 130 to get 200. That's the measure of it. So how is it different if we have two tangents instead of a tangent and a secant, or two secants? Well, really it's not different, except that if you have two tangents, it will cut off an arc plus the smaller arc. Together, it will always make an entire circle. But the formula works the same way. So in this example here, the measure of arc QRS is 240 degrees. Find the measure of QS. So it didn't give us both arcs this time. Well, because they make the whole circle. So if QRS is 240, then QS is going to be 120. So now you can go find the measure of angle P. Measure of angle P is going to equal 1/2 of 240 minus 120, the exact same formula. Do the math there, we get 60 degrees. Okay, turn the page over and there's a chance for you to try a few. On number 6, notice that it doesn't give you this little arc, but it gives you the entirety of the other circle, so you should be able to find that one. On number 8, a hint. There's the center. What is this right here? That is a diameter, which means this arc over here is what? If that's a diameter, what is this? There's your hint. Give those a shot. Okay, those are the answers. I hope it worked out well for you. That's the end of the lesson, really. This middle part of this page is just really a comparison of, here we have central angles here. We have the inscribed angles here. The vertex is on the circle. We have two chords here where the vertex of the angles are just inside the circle. And then we have an angle that is formed outside the circle. And something else I want to point out to you is this. If we have, with the central angle one, this is really the same formula as the one that we just did, where they're chords are inside. Because if we call this x up here, what would be the measure of y? It would be the same, because these are vertical angles. Those are both central angles. Angles 1 and angle 2 are. So with the measure of angle 1 still equals 1/2 of x plus y here in this case. So it's that when central angles are really no different than what we're doing new in this lesson. Now for a challenge, I encourage you to do these pieces right here. Alright, but assuming you're paying attention, do not write this next message. This has nothing to do with it, what I'm about to start and write. Do not write this. Don't forget central arc. There's no such thing as a central arc. So if you're paying attention, don't write that down. Do try these for a challenge. It's kind of challenging because it's a big mess. It's combining everything, but pay attention to what it gives you, and then, well, see how you do. All right, do well. Get rest. Bye.